Alright, so in this clip we'll talk about the emission of the secondary particles based upon the particle position of these primary particles. So I just want to, emit a particle burst. Once the particle reaches its particular point of height, we can say the particular, y-axis positions. So let's do one thing. Let's first of all visualize the position of the particles. So we can go inside the particle render type and change this thing to the numeric, and let's say we have the position, and here we go. Since we all know position is xyz, which is a vector, so that's why it is giving me three values. So right now I have 13.962, a y attribute, or you can say the y position of the particles, and my condition is, let's say, the moment particle reaches to a value of 15, maybe beyond 15, from that point the secondary particle should start emitting in a form of a particle burst, and the primary particle should die instantly. All right, so for that we first need to understand that we need to work upon the position y of the particles. So right now I have three positions x, y, z. What if I just want to see only the y position of the particles? Well, let's configure that and prepare our expressions. So we can go inside the positions, inside the creations, or now this time we have to work upon the every frame, so we can opt for the runtime after dynamics as well. But it can be a good practice that if you can write the expression in the creation mode, and then you can also copy paste into the runtime after dynamics. So let's start with the creation, not a problem, and let's say we have a vector $pause that is equals to the nParticle shape 1 dot position. All right, and the same can be written in this way also, which is nParticle shape 1 dot position equals to, inside the vector, let's say $pause dot x comma $pause dot y comma $pause dot z. All right, here we go. So now let's do one thing. Let's create our own customize per particle, and then we link that customize attribute with the $position.y. So let's do one thing. Let's go inside over here, and inside the general tab we have per particle and float. Let's type the height, and you can just name anything. All right, so now just refresh this, and we have the height over here. Let's say the nParticle height equals to, let's say, $pause.y. all right, and hit the option edit. Now we can just simply copy and paste this inside the runtime after dynamics, create this. All right, now over here, instead of writing the positions, we can use the height, and notice what we have. We have 13.962, which is the previous values of the positions, because now we have linked the position y, the particle position dot y, with the height, which is a per particle customized attribute. All right, now let's prepare a statement that the moment particle reaches the value, maybe beyond 15, then the secondary particle should start emit in the form of a burst. So first of all, the question comes, how do we emit these secondary particles? Well, that's pretty straightforward. Let's bring it back to the spare mode, select the nParticle 1, go to the nParticles menu. Over here we have the emit from object, and now I can pick the emitter type, let's say omni, and can hit the create. But there's one problem. Well, if we use the same nucleus, then it might be a problem that you'll run with some issues. I'll do one thing. I'll just create this and show you the issues. All right, now the moment you play, you can see that there's something is wrong. It's not actually the blue particles which are driving the nParticle 2. It's actually the nParticle 2 which is now driving the nParticle 1. This is why, because both of them are sharing the same collision layer. And one more thing, there is some problem with the per point emission rates. So once you use the same nucleus for the two particles, and if you wanted to use the per point emission rates, with the help of this only, we can achieve the point from where we want the burst of the particles. So we are required to use this also, and I've experienced that there's a kind of a bug which slow downs the primary particles. So let's do one thing. Instead of playing with this, let's rewind the timeline and delete the particle system and select the first particles, play the timeline. Now instead of using the same solver, we create a new solver, and here we go. Now this will be good. There won't be any problem. If you play the timeline, you can see the particles are moving and the secondary particles have started emitting from the primary ones, of course. Now for the moment, let's disable the gravity of these points by ignore solver gravity. All right, and now the question is, once the particle reaches the value of 15, only then the particle burst should take place. But right now the particle burst is taking place from the beginning only. So we can tackle this thing by using the per point emission rates. So let's select the emitter 2. Going inside the nParticle's menu, hit the option per point emission rates. The moment you click this, you'll see now your emitter will no more responsible for the emission of the particle, but the emitter 2 rate per particle has been assigned to the nParticle shape 1. Now the emitter 2 rate per particle is the attribute of the per particles, and now you can control the rate of nParticle 2 from this. So let's go inside, and first of all let's play the timeline. You see nothing is happening because there's nothing inside the emitter 2 rate pp. So let's draw the condition what we have. Let's say inside the runtime after the dynamics, if nParticle shape 1 dot height is greater than, let's say, 15, then nParticle shape 1 dot emitter 2 rate pp should equals to, let's say, 1000. All right, and with this we are good to go. And just make sure that you type correctly. It is emitter 2 rate, R is capital, and pp, I think so we have done a mistake, it's pp. No, it's fine. Hit the option edit, and let's say copy and paste this inside the creation as well. Not a problem. So now if we play the timeline, we should notice, yes, something nice is happening, but there's again a problem. I don't want the simulation to be in this way actually. Well, our condition is getting satisfied, our expressions are working, but the behavior is not actually nice. So we can control this. Let's do one thing. We also need to dye the primary particles, and we also need to control the rate of emission of this the secondary particles. So that can be possible if we use another thing, that is once the height is greater than 15, we have the emitter to rate pp set to 1000 particles, but along with this we can also give the lifespan pp to the -1. So the moment it crosses the value of 15, it will die instantly. So nParticle shape 1 dot lifespan pp equals to -1, and there we go. So now it's fine, and yes, you can definitely improve the overall speed and timing of the particles by going inside the emitter 2, and let's say we increase the min and the max distance, and let's set the speed with the 5 to the 2. And now if you play, you can see this is what we are looking for. But we can also reduce the overall lifespan. So let's say we use 0.35 to 0.25. all right, and we can also change the particle type to the streak, let's say with the tail size 3 and tail fading to the 1. And now if you play, there we go, pretty much nice. And we can also increase the overall speed of the particle. Let's say we have 25 by 10, and we can increase the spread. So by doing this, we can include much almost all the particles, and just take a look at the nice variations we have. Some of the particles are going in this particular direction, so the particles are not even able to make to the value of 15, and this is something really very nice. All right, I hope so guys, you must have understood the concepts of the per point emission rates, as well as using the different nucleus solver. And of course we worked upon the single attribute of the position, that is the position y. So now let's talk about the effect of fields on per particle basis in the next clip. All right, so let's get started with the next one.